Okay, let's go ahead and get started taking our cycles or biogeochemical cycle notes, starting with an overview of the water cycle. Now, Earth's water must be recycled. Earth's water must be recycled to ensure a steady supply. So Earth's water must be recycled to ensure a steady supply. The water cycle is the continuous process by which water moves from Earth's surface to the atmosphere and back. Okay, so the water cycle is a continuous process by which water moves from Earth's surface to the atmosphere and back. Now, there's another word that could be used for the water cycle, and that's the hydrological cycle. So over to the side, I want you to write hydrological cycle. So that way, if you ever saw that term, you would know, hey, that's the fancy term for the water cycle. We know that hydro means water, and a cycle is a continuous process. No end and no beginning. Okay, so a cycle is continuous, there's no end and no beginning. And so that's how the water cycle is. Now we're going to talk about 4 main steps to the water cycle, but it could start at any place within the water cycle or stop at any place. But these do occur usually in a specific order. So there are 4 main steps. We'll talk about evaporation, condensation, we also have precipitation, and accumulation. Okay, so 4 main steps. We have evaporation, condensation, precipitation, and accumulation. Now, how does that water get pumped through all those different steps? Well, you need to make sure that you know that the sun acts like a heart So sun acts like a heart that pumps this energy between the hydrosphere and the atmosphere. Okay, so the sun acts like a heart because it pumps energy. Just like your heart pumps blood through your body, the sun is acting like that heart because it's helping pump that energy, that water, between the hydrosphere and the atmosphere. And the hydrosphere is any surface, any place where there is water. So it could be a lake or a pond or an ocean or even the swimming pool, anywhere on Earth's surface that has water. And the atmosphere, we'll study that in the next unit, talks more about, well, this Earth's surface out into space. So the sun acts like the heart that pumps that energy between those two places that makes that cycle continuous. Now, the first step of the water cycle that we're going to talk about a little bit more is evaporation. Now, evaporation is the process by which molecules of liquid water absorb energy and change to a gas. Okay, so evaporation is a process by which molecules of liquid water absorb energy and change to a gas. Now, the evaporation of liquid water to a gas creates something called water vapor in the atmosphere. And so let's go back up and look at the word evaporation. Even has vapor in it. So let's underline where it says vapor within the word evaporation. And in your head you can think evaporation. Oh, that's right, because it turns from liquid to a gas, and we know that that liquid or that gas that's created in this step is called water vapor. Now, the energy for evaporation comes from the heat of the sun, which is what we just talked about. So the energy for evaporation comes from the heat of the sun. And so that's what we just discussed on the last slide. We were talking about how that sun acts like the heart that pumps that energy through the water cycle between the hydrosphere and the atmosphere. And it's what causes evaporation to change from a liquid water to a gaseous form. So there's two ways to create water vapor from evaporation. Two ways to create water vapor from evaporation. First, you have liquid water that can evaporate from surfaces. So first, liquid water can evaporate from water surfaces, like the surface of the ocean, surface of lakes, or the surface of puddles or even ponds. And then the second way that you can create water vapor is through living things, because living things can give off water. Okay, so some examples might include plants that release water vapor from their leaves, which is a process called transpiration. Okay, so that's a process called transpiration. So this is actually how plants sweat, essentially. So think, we perspire, we have perspiration, that's how humans sweat, but how plants sweat, well, that's called transpiration, and that's when they release water vapor from their leaves. So out to the side, I want you to write plant sweat. Okay, transpiration. So that's how plants release water vapor from their leaves. And that's one way that living things can give off water. And also, mammals like us release water vapor when they exhale. Okay, and that process of breathing in and out Well, has a fancy word. You probably should know it. It's called respiration. Okay, so transpirations, plant sweat, respiration, when mammals breathe in and out. So why don't you try breathing on your hands? So cup your hands over your mouth and then breathe out onto your hands. Can you feel that? There's probably some moisture that's on your hands. So you know that you're releasing water vapor when you exhale. But why is it kind of wet or damp? Well, that's our next part that we're going to talk about. It's called condensation. So let's figure out why when you breathe out on your hands, the water vapor, because we know that when we exhale, there's water vapor, why it then feels kind of damp on your hands. Well, in the water cycle, as the water vapor rises higher in the atmosphere, so as the water vapor rises higher in the atmosphere, it cools down. Now the water vapor then turns back into tiny drops of liquid water. So condensation is a process of a gas turning to a liquid. Okay, so we know this is condensation. So whenever you put your hands over your mouth and you exhaled water vapor, whenever you felt that dampness on your hand, that was that gas, that water vapor, that hit your hand and cooled and returned back to a liquid. And that was an example of condensation. So how do the clouds form in the water cycle during this step of condensation? Well, there's water droplets that are in the atmosphere that will collect around particles of dust. And that's what eventually will form what you see as clouds. Okay, so let's take a look at the formation of clouds. Okay, and we know that water accumulates in maybe an ocean or a pond or a river or a lake, and the sun heats up water and causes it to evaporate off of the surface, which was what we just talked about. Now the water vapor continues to rise higher in the sky because vapor we know is a gas and it's able to rise. And the water vapor condenses as it cools. The higher it gets in the atmosphere, the cooler that gas is going to get until it condenses back to a liquid drop. And those liquid drops, see the little drops? They're mixing with the dust. There's some little dust particles in there. And eventually, when they mix together, that's how the clouds are then formed. You can have other examples of condensation that you might see around your house that aren't necessarily a cloud. So, for example, you might see condensation on a plant. Okay. So there's some condensation on the plant. We said before that plants release water vapor through their leaves called transpiration. And here's an example of, well, it is cold outside and it cooled that water vapor. And just like you felt that dampness on your hand, well, that was condensation. Here's an example of how that would happen with a plant. How it was cool outside, that plant was sweating, it was releasing that water vapor through transpiration, and it cooled from a gas back to a liquid. And then you see that dew on the plant, which is an example of condensation. I think we need to talk about the different types of states of matter to make sure that you understand those. So I want you to draw little boxes at the bottom of your page, wherever you find room. Okay, and we're going to take a look at the way that the molecules work for solid, liquid, and gas before we go on. Okay, so we have solid, liquid, and gas. Now these are our three states of matter. Okay, so write 3 states of matter. Because we're talking about evaporation and condensation and how they're changing in evaporation from a gas to a liquid and in condensation from a liquid to a gas. So let's make sure that we understand what those molecules and atoms would all look like for a solid or liquid or gas. Now, for a solid, can you walk through a solid? No, you can't walk through a solid. So these are solids have atoms that are very tightly packed. So what would a solid look like? Well, all of these little atoms, and the circles represent the atoms, would be very tightly packed together. There wouldn't be any way to get through it. Because just like the tabletop is solid or the door is solid, you couldn't walk through it because all the atoms are tightly packed together. So draw your atoms where they're all tightly packed together. Now, if you go on and think about the atoms that are involved in making up a liquid, well, can you walk through a liquid? Can you walk through when you're in a swimming pool? You can swim in a swimming pool. So you know that you can walk through that, and the atoms aren't very tightly packed together. But when we talk about a gas, well, do you walk through a gas? You do, right? You walk through the air, and the air is a gas, and which is easier to walk through? Like the liquid in the ocean or a swimming pool, or the gas in the air that you walk through every day? Well, the walking through the gas is a lot easier. So when we talk about how those atoms look, we know that the gas molecules are very far apart. Okay, that's why it's so easy for you to walk through those. Okay, but your liquids, they're not as tightly packed together as your solid, but they're a little bit more denser than a gas. Okay, so once you draw your little atoms for a liquid, where they're kind of not as tightly packed as a solid, but closer together than a gas, and then you have your gas where they're a little bit more spread out. So that way when we say, okay, evaporation is when we have a liquid turning into a gas, which makes water vapor, you have an idea of what that will look like. And when we say condensation is when you have a gas turning back into a liquid, then you know what that looks like as well. We're going to stop here for part 1. Part 2 will start with precipitation. Thanks for listening.